Here you can see the result of applying Bayes' rule for the localization posterior. To define the likelihood term, we swapped the state and the observation at t, and also take into account all other conditions. The prior and the normalizer are also conditioned by the previous observations, all controls, and the map. It is totally fine here to condition Bayes' rule on arbitrary random variables like the controls, like our observations, and the map. And please take a look at this. If you remove the additional conditions in the posterior, you would end up exactly with the general Bayes formula. We call the likelihood term the observation model, which describes the probability distribution of the observation vector t under the assumption that the state xt, all previous observations, all controls, and the map are given. The prior is called the motion model. It is a probability distribution of xt given all observations from 1 to t-1, all controls, and the map. Take into account that no current observations are included in the motion model. To simplify the normalization part, we define the normalizer as eta. Eta is 1 over the original normalization term, and this term is a sum of the products of the observation and the motion model over all possible states xti. This also means you only have to define the observation and motion model to estimate the beliefs. So, let's discuss these two terms more in detail. What you see here is again the definition of the motion model. The problem here is that we have no information where the car was before, at time t-1. This means no information about the previous state xt-1. Now my question is, what kind of rule or law can we use which will help us here?